Okay, this is part 2, and we're looking at measures of central tendency. So we've talked about kind of all of our vocabulary, and now we want to find, in this one we're going to find the population mean or the sample mean as indicated. So the first one wants us to find a sample mean, so that means we're going to be using X bar. And the sample mean, okay, if you have a small data set such as we have here, you just take these numbers, so 20 plus 13, you add them all up. And then I'm going to divide it by the total number. So there are 1, 2, 3, 4, 5 entries. So I'm going to divide it by 5. And when I do that, I get the value of 11. So the sample mean, X bar, would be 11 in that case. So very straightforward calculation when the data sets are small. Now if it's population, okay, that's going to be the Greek letter mu. It's our parameter. And we would just take, again, all of the data points, add them together. So the calculation is no different between sample and the parameter. This will change when we get into later things such as standard deviation and variance. Okay, so we'll add them all up, divided by, I believe there's 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. Okay, so then if I punch that in, I get 15. Okay, so just remember, if it's a sample, then the mean is X bar. If it's a population, the mean is mu, that Greek letter. Okay, now number 12, this one's going to test our understanding of the median a little bit. So remember, the median is the middle number. And we want to know, so we're given that the median of the data set is 26.5. So our data points are 7, 12, 21, and then blank, and then 41 and 50. And the median is, again, that middle number. Now we have an even number, so the median is actually going to be the average of these two numbers. But we don't know what this number is. I'll just call it X. And so since we don't know what that is, but we do know that the median is 26.5. And it's going to be somewhere, it's the number right between 21 and this number X. So what we can say is we can say the median 26.5 is equal to 21 plus whatever X is divided by 2, the average of those two numbers. Okay, and now I just have a basic equation to solve. So I'm going to times both sides of my equation by 2. So this will give me 53 equals 21 plus X. And then I'm going to subtract 21. I'm going to have to pop over here. 53 minus 21 is 32 equals X. So this data point right here is going to be 32 because if it's 32, then our median will be 26.5. And you can check. You could do 32 plus 21 divided by 2, and that does indeed equal 26.5. And so that's how you would find a median if you're missing a value, a single value. But again, remember the median is right in the middle, and we had to find the average because if I try and make my way to the middle, so like if I were to take this off, then I would land somewhere between these two, so we have to find the average of those two. Okay, number 16 says the following data represents the flight time in minutes of a random sample of 7 flights from Las Vegas, Nevada to Newark, New Jersey. On United Airlines, we want to compute the mean, median, and mode of this data set. So the first thing I'm going to do is I'm going to put them in ascending order. So it's 257, then 260, and then there's another 260, and then there's a 266, and then a 267, then a 270, and then 282. So I've got them now in ascending order. So there are 7 flights. So what I'm going to do is I would add them all up. So I would add 257 plus 260 plus 260 plus 266 on up. And then I would divide that by 7. And this is a sample, so it tells us sample, so this is going to be x bar equals, and when I add all of those up and I divide it by 7, I get 266 as my sample mean. Okay, the median is the middle number. So one way you could look at this, there's not very many data points, so you can probably see it, but since it's odd, then you just take the number plus 1 over 2. So the total number of data points plus 1 over 2. So in our case, you would take 7 plus 1 over 2, which is 8 over 2, or 4. So it's going to be the fourth one. So you have 1, 2, 3, 4. So there's our median right there, 266. So median, capital M, is also 266. Okay. And then lastly, the mode. Just look at and see which one occurs the most, and I see 260 twice. So our mode is going to be 260. Okay. So notice though, as we start to increase our sample size, these calculations can get more and more tedious. So I'm eventually going to show you how to use this in StatCrunch. But this one right here, what I want us to do is we're going to look at and try and match the histograms. So so for this first part I, we have the mean and the median are the same. If you recall, when the mean and the median are the same, then these were symmetric. So I'm looking for a symmetric graph where the mean and the median are about 42. And if I look at part D, okay, part D looks like that would be about 42 in the middle there, and it's relatively symmetric. And so so part D is going to be the letter I. Okay, then letter 2, you have that the median is greater than the mean. So remember, when the median is greater than the mean, that tells us that that our data is going to be kind of a left skewed. It's going to be pulled by some extreme values to the left. And if I look at these, so part A is looking relatively symmetric. Part B would actually be more of a skew to the right. Okay, but part C, they're definitely going to be skewed left there. So this part C would be 2. Okay, part 3, and this one we have that the median is less than the mean. So I should have wrote this. This was skewed left. When the median is less than the mean, that means the mean's being tugged to the right. It's bigger. And this was the skewed right. And skewed right is where the tail's going off to the right is answer B. Okay. And so then by default, this obviously has to be 4. But if you look, the mean and the median are almost the same. So the mean is approximately equal to the median. So that tells us it's going to be roughly symmetric, which here we are roughly symmetric. You know, they look pretty good, and we're lined up on 32 here in the middle of our relatively bell-shaped curve. So that would be a symmetric distribution. All right, so now we're going to look at a couple of things. So we've got a couple of data sets, tap water versus bottled water, and the pH in water. So the acidity or the alkalinity of a solution is measured using pH. So when a pH is less than 7, then it's acidic. A pH greater than 7 is an alkaline. And the following data is going to represent the pH in samples of bottled water versus tap water. So each one of these represents a data point that was observed or gathered. And we want to determine the mean, median, and mode pH for each type of water, and then we'll kind of talk about their differences. Okay. And this is where I want to introduce StatCrunch. So I've got my data set right here, and I want to show you how you find the mean, median, and mode when you have a data set. So I've got the tap water's pH and the bottled water's pH. So what I'm going to do is I'm going to go under Stat, and then I'm going to go Summary Stats by column, because these things are in columns here. And then I'm going to highlight both of these. And if you look down here, we've got the mean. So N is the number of entries, the mean, the variance, standard deviation, standard error, the median's in there. There's all kinds of stuff in here that we'll eventually learn about. And then I need to get the mode in here too. So on a Mac, you're going to hold down the command key and click on mode, or on a PC, you can hold down the control key so that you keep all of these things highlighted. And I'm going to compute, and now I've got the mean of the tap, the mean of the bottled, and then here's the medians, and then at the end are the modes. So I'm going to jump over here and write those down. So for the tap, the mean X bar was equal to 7.5. The median was equal to 7.485, and the mode was 7.47. Okay, and then when I looked at the bottled water, okay, the mean was 5.19, the median was 5.22, and the mode is 5.26. So we've got our information, and notice that the mean and the medians for the bottled water are much less than the tap water. And so what we could say here is, bottled water, so you're more acidic if you're less than 7 on the pH scale, and the bottled water tends to be much less. So the bottled water in this observation is more acidic. And so that would just be one observation. We could look at other things, but the biggest thing I noticed there is that discrepancy of the level of acidic, or the pH levels, and that bottled water appears to be much more acidic in this observation. It's not to say for everything. Okay, now part B down here says, suppose that the pH of 7.10 in the tap water was incorrectly observed or recorded, as 1.7. How does this affect the mean, the median? And we don't need this part of the question. We just want to know, how does it affect the mean and the median? So I'm going to come back over here, and I'm going in the pH of the tap water, the 7.1, I'm going to change this to a 1.7. Okay, so I'm going to close this out. So again, I'm going to go under Stat, Summary Stats by column. This time I only need the tap water, and we're dealing with just the mean and the median, which are highlighted. And notice that the mean is now 7.05, and the median is 7.485. So when I do this, the mean is 7.05. and the median is 7.485. So notice that it changed the mean. It dropped it quite a bit, dropped it by 0.45 when I compare the two means. But then the median is 7.485. So what this tells us, what we can observe is, this is just an example that the median is more resistant. So we changed one value, and that mean dropped quite a bit, but the median did not change. So the median is more resistant to that one minor error or a big drop in